Hi, this is a short video to show students in grade 10 mathematics in Ontario how to calculate the distance from a point to a line. And when you get into grade 12, there is a slightly shorter way of doing this. They use the standard form ax plus by plus c equals 0, and there's a way of using that in the calculus vectors course to find the distance, maybe a little bit faster than the process that we're going to go through here, which is quite long and slightly convoluted, it will seem. Nonetheless, it is good practice for calculating distances from a line using Pythagoras, and also just generally finding the equations of lines. So in this example here, we got to calculate the distance from the point 3 minus 1 to the line 2x minus 1. So 2x minus 1 kind of looks something like that. And you'll have gotten from the previous diagram on the other slide that the closest distance, the shortest distance to get from a point to a line, is actually to go perpendicular 90 degrees to that line. So we can visually inspect this and sort of eyeball an approximate solution, and then we'll use the algebra to get an exact answer, but at least we can see if that exact answer makes any kind of sense with relation to the graph. So the steps up here, let's calculate the perpendicular slope. What we're going to do first of all is I'm going to look at this line, and then I'm going to use the perpendicular slope to that. Then I'll figure out an equation of this line that connects the point I'm working with and whatever point it hits on this line. I'll find the intersection of those two lines, find that point there, and then finally, once I've done that, it's just a matter of using the Pythagorean formula to find the distance between the 2 points. Okay, so step 1, calculate the perpendicular slope. Well, we know from here that m1 is 2, that's the slope of this line, so if we take the negative reciprocal of that, we will have the slope of this perpendicular line. So m2 in this case is minus 1 over our slope, so minus a half. Now let's find the equation of the perpendicular line that connects to that point. Okay, so remember, to find the equation of a line, you just need a point and a slope. So what I'm going to do is plug in this point and this slope and derive the equation of this line here. So the point I will use will be 3 minus 1, so y is minus 1. M, we said we're going to use this one here because we're finding the perpendicular. We're using that point, so x is 3. Okay, let's see if we can now find what b is and come up with a complete equation of this line. So minus 1 equals minus 3 halves plus b. Add this over here, so that's like 1.5. So minus 1 plus 1.5, put us at a half. So a half is b. So we now have our equation will be going back to this form. Will be y equals minus a half x plus a half. Okay, so what we have just done there is find the equation of this line. Let's just visually inspect that and make sure that makes sense. Definitely a negative slope, minus a half. Yeah, it looks like for every one you go across, you're going down by about a half, maybe. Kind of looks like it could be 1 as well, but that's the weakness of diagrams, particularly small diagrams. And plus a half here, yeah, it looks a little bit off there, so I'm wondering maybe my initial drawing I wasn't quite at a good right angle and my initial line here wasn't so great. So what I'll do after this is just check my answer using GeoGebra software. Okay, so for now we got the equation of the perpendicular line. That's going to get us a long way here. Let's move to another slide. So y equals minus a half plus a half. And the other line was 2x minus 1. Okay, so I have two lines, and I'm going to find where those two lines intersect each other. Oh yeah, now that I kind of redraw this, I can kind of see, like, yeah, my equation makes a little bit more sense here if I draw that a little bit better. I think I underestimated the right angle, how big it was. That looks better. Okay, let's find, what we'll do now is let's find this intersection point. So in gradient slope form, both the equations are equal to y. So you can just say they're equal to each other. So I'm going to say 2x minus 1 equals minus a half x plus a half. Collect my like terms, so let's put this over here. So I got 2.5x, and let's put this over here. So I got 1.5. Okay, let's try and do this using top-heavy fractions. So that's 5/2, 3/2. Actually, now that they're both the same denominator, you could just equate those and say that 5x equals 3 if you want. Or you could do 3/2 divided by 5/2, which is the same as multiplying by the reciprocal 2/5. Either way, you should get this. X equals 3/5. Okay, we will then put that solution back into one of our equations to find the y value that matches up with that pairs up with it. May as well do the one that's got slightly easier numbers, so we'll just use this one. We'll say y equals 2 times 3/5 minus 1, and you would get 6/5 minus 1, which is the same as 1.5 minus 1, so y equals 1/5. So we think that this point here, let me just label that out here actually, this point of intersection here, we're suggesting that is about 3/5, 1/5. And the diagram suggests that, yeah, that could be right. I don't think we've made any errors there. Okay, so the point 3/5, 1/5 is now a coordinate that we can solve using Pythagorean theorem. We can find basically the distance of these lines here. So I'm going to find the distance from this point to this point, to the point 3 minus 1, sorry, there it is, and this point. And I'm just going to use Pythagoras' theorem because it really is just like finding the hypotenuse that connects this width and this length, or this height here. So I'm going to find the difference there. That's x2 minus x1. And I'm going to find the distance here, y2 minus y1. And then I'm just going to use Pythagoras. So, okay, so let's just write down what we got so far here. We found the intersection point 3/5, 1/5. So when we did our equation of a line, that connected to 3 minus 1. We're saying this point where they intersect here, this is about 3/5 of a fifth. And what we can do now is just use the Pythagorean theorem. So essentially it really is just like finding the width and the height and then figuring out the hypotenuse of that triangle. So if you ever forget how this works, we're just drawing the diagram and reason it out that way, because again, this width is the difference in the x coordinates, right? So when you say L equals y2 minus y1 squared plus x2 minus x1 squared, you're really just saying find your a side and your b side, or find your width and your height. So the difference in the y values, that's going to be the height there. So what have I got for difference in y values? I have minus 1 minus a fifth, square that. And then finally, I will have for the x values, oh, by the way, let's just clarify, this is x1, y1, because it's on the left, right? And this is x2, y2, because the point further to the right. So make sure you get those the right way around. X2 is 3, and then we are subtracting this value and squaring, so little bit awkward here with the fractions, so I'm going to make this -1 1/5 is -6/5, and this will be 2 2/5. So if I make that top heavy, that's 12/5. So now I'm going to find the square root of 36 over 25 plus 144 over 25. That's the square root of 180 over 25. And then let's just put that into a calculator actually to get an exact value for that, shall we? We know 25 square roots, of course, exactly, but 180 won't. So when we square root that in a scientific calculator, we get 2.68. So let's just see, does that make any kind of reasonable sense with regards to our diagram? And even just kind of, I know it's a diagonal line, but just kind of eyeballing according to scale. Yeah, looks like we will be definitely between 2 and 3 units for the length of this line that connects those 2 points. And again, that is the shortest distance from this point to this line. Thank you.